y'all, we're back here for the final episode that I'm calling the extras. And like what we're going to be doing today, none of these things are what I would consider like mandatory kind of upgrades, but these are the things that to me are well worth doing. They're not a lot of money and they just kind of finish off this project nicely. So the last little bit that we're working on here, one of the things we've done is we installed these Mundorf aluminum oil 0.22 UF caps, and lowering the UF of this cap definitely, to me, helped the frequency response. The other thing we did is we installed these 270K 2-watt grid leak resistors. The ones the amp came with were 330K. Given that the tubes aren't being pushed very hard, they're being pushed at 70%, I believe is what the final number came up to. So I feel like 270K is a safer value of the grid leak resistor, and it's definitely way better than having that 330K in there. The other thing that I did is anything that you put in the cathode of a tube is in the signal path and is going to make a sonic difference in the amp. I didn't trust the capacitors that they used in the cathode bypass on the 300Bs. So I got some Audio Note 100 UF 100 volt caps to put in that position. You could probably get away with using like a Nikon or any kind of really quality cap. You could even experiment with putting some bipolar caps, which some people say sound better, but I felt these Audio Notes were a good price point for being high quality without being just ridiculously priced. So we put a pair of those in. I'm going to switch the camera angle so you can see this next modification a little easier. Okay, the other thing I noticed in this amp is they didn't use any grid stopper resistors. And while I didn't see any like serious oscillations, it's always a good idea to use grid stoppers to help subdue any oscillations that might end up getting started. So I showed you where we put the 1K grid stopper in the signal path going to the grid of the lower section of the Cathode on the front end. Well, they had just a jumper wire going from the circuit board up to the grid of the 300B. And so we've installed a 2-watt 100 ohm grid stopper on the grid of the 300B. And let me zoom in here, and there it is right there. And it just goes between this grid, and you can see it's marked G for grid. It just goes in there like that. Easy modification, and just gives us a little assurance that we're not going to have any problems with oscillations. So in this last modification, it's going to have really no impact on the sonic qualities of the amp. This is more of a reliability thing. A friend of mine online pointed this problem out, and now I see that it really is going to be a problem. This is the cathode resistor for the 300B tube, and it's got about 5 watts of power running through it constantly. And while it's rated at 25 watts, that was assuming that this was going to be bolted to a chassis or something else and not just be floating in free air. It's still rated 5 times what the actual wattage is, so it probably will survive. But the problem is, right next to it you've got this cathode bypass capacitor, and here's the capacitor that's filtering the DC going to the heaters on the 300B. You never want to have a lot of heat near capacitors, so this is bad for that reason. The other problem is, because we're looking at the amp upside down, the heat is going to go that direction. And so all the heat's going to go like underneath these capacitors over here around this, over just to the other side of this. Let me show you what I'm talking about. Here's the rectifier for the DC. Here's another big capacitor right here. And so this heat is going to get trapped underneath all of these components and just bake them. The other thing it's going to do is it's going to cook this circuit board. And it's going to end up delaminating, or you're going to have some other problems with this circuit board. And given where this thing is manufactured, we know there's not going to ever be any parts available for this thing. So when the circuit board's cooked, that'll be the end of this amplifier. I did want to point out too, since we jacked up the B plus and we replaced this cap, or made sure that this cap was a 500 volt instead of the 450 that I originally used. This cap, this big guy here, it's also rated at 500 volts. So we're perfectly within specs on our B plus. I just want to kind of add that in because I don't think I talked about that. So we have these two screws here that come in from underneath that are mounting the potted output transformers. And that looked like a really good spot for us to attach this piece of angle aluminum to. So we're going to drill some holes and mount this guy over here on these two screw holes. Probably going to be right about there. And then we're going to unsolder this resistor. We're going to bolt it over here to this piece of aluminum and then run wires over to the circuit board and put this resistor as far away in this corner as we can. And between this aluminum and then this being bolted down to the chassis, it should transfer the heat. You know, this aluminum can dissipate some of the heat to the air around it and go out these vent holes that are on top. The heat's going to rise so it doesn't get involved with all these capacitors. It's going to keep the heat away from these guys. And also, like I said, being bolted to the chassis, some of the heat's going to get transferred from this aluminum through the chassis, and it's going to help keep this area of the amplifier cooler. So this modification is more for reliability than performance, but I still think it's a good thing to do. So let me get my soldering iron hot and we'll get to work here. Okay, so got my soldering iron all hot. You want to turn the heat up pretty good. This is pretty large diameter wire we're going to be desoldering here. And this isn't a real difficult thing. You heat this joint up on one side. And it may take a couple of seconds for it to melt the solder. Like I said, it's a pretty big wire. And then once you see it moving, just pull it up like that. Then we want to get this wire out of our way so we don't cook it. And then come in here, probably come in from this side. Watch you don't cook that capacitor while you're heating this up. And off it comes. Now you can see here where they had some holes drilled in this board. And my guess is, at one point they thought it was a good idea to bolt that resistor down to this circuit board. And I have a feeling they were quickly getting returns on this amp with this circuit board getting roasted from the resistor being bolted to it. So they made these little stands and then floated it up in the air above this board. But I still think it's going to end up cooking this board. So now I'm going to show you how to detach the leads from the resistor itself. Okay, so as you can see, I've got my big wood clamp here. You could use a C-clamp with a little piece of wood on it or something to clamp this down to a bench, because it's kind of hard to hold the soldering iron, the resistor, and pull on this lead all at the same time. So I'll show you how I get this off. You grab this lead, you heat up the joint, and then they've got it wrapped around pretty good. Again, unfortunately, they really wrap this thing up tight. You may even have to use the tip of the soldering iron to kind of hold one end of the wire as you twist it, and it should come out now. There we go. You can see that was a little bit more of a struggle than it really should have been, but because of the way they really wrapped the lead around it, it made it a little harder to get out. Then you want to warm this thing back up, and then get a little jeweler screwdriver or something, and open the hole up so we can put the solder the lead onto it. So let me do that to the other side, and then we'll get back to work on fabricating up this heatsink we're going to be using. So I'm going to show you a little trick for measuring the holes so that we know where to drill the mounting holes for our heatsink. And we can't get something down in here to directly measure that, so we're going to make a little template. You bend up a piece of cardstock like this, or kind of thick paper, and you want to get it where you can put it down in here, and it's a width that you can get both the holes on the same piece of paper. So you put it where the paper is over the holes like that, and then you come in with 2 fingers and hold it in place. Then we get a Phillips head screwdriver, turn it back and forth a little like that, then come down here, find the other hole, and do the same thing. Make sure you're holding it down fairly tight so it can't move. And now you've cut a couple of holes in this piece of paper that are the distance between these 2 holes. And if you're going to be doing any metal work, you need to get just a pair of metal vernier calipers. Don't get the kind with the dial and the electronics on it. Just spend the money and get some good, stainless. This is made by Central Tools. I've had this for at least 25 years. They last forever. You'd probably be better buying a good quality one used than buying some super cheap one new. So anyway, we're going to measure across these, find the center of these 2 holes. We're not building a spaceship. We can, it's just got to be pretty close. And when I look at it, let me double check this. That looks like 69 millimeters. So then the next thing we do is we get the piece of metal that we're going to be using for our heatsink. And you put one end of the caliper down on this end where there's a little bit overlapping. And then you go down on this end. Now you kind of bear down on this side and you go like this. And you scribe that in. And then you bear down a little bit on that end and scribe this side. Now to get the other hole, we want to make sure that we're not getting into this curved part right here. And so I decided about 16 millimeters looks good. So you go like this, scribe the crosshair, come down here, scribe the crosshair. And now we have, it's kind of hard to see with the light, but yeah, I don't know if you can really, yeah, there you go. You can see it. You can see this one down here where I've scribed the X. So I went ahead and did the other side, and I punched, got a center punch, punched the holes and drilled it, and have bolted it down to the other end. So let me slide this over. And so now we've got this angle aluminum screwed down with the 2 holes on this side of the output transformer. So then we need to figure out where we're going to put the resistor. So we want to get it down here as far away from this as we can without this lead getting too close to the screw. And we're going to have to mount them at an angle. so we can get both the holes into this piece of aluminum. Because if we go like this and get into when we get into this curve down here, this bolt hole here was going to be off the end of the aluminum. And I know it's kind of hard to see, and the lighting's not great. But it's going to be sitting there kind of an angle like that. I'll get a better camera angle when I get it bolted down. But then you want to get a little screwdriver and scribe along this edge and along this edge where the resistor is going to sit. And then we're going to take this piece back out, mark the 2 holes, and mount the power resistor to this heat sink. So let me go do that and then bolt this back in place. I'm going to go ahead and do both sides. Okay, so we have our 2 holes drilled that are mounting it down to the output transformer hold down screws. And then we've drilled the 2 holes that are going to hold the power resistor to the heat sink. And you can see I bent this lead up just a touch. And we can have our screw with our lock washer. And we have plenty of gap here between this lead and this screw head here. So we're not going to have any issues there. I got this down on this end as far as I could because, again, the circuit board's going to be down on this end. So the next thing we do is, and I did get my little flat file, and I kind of knocked the corner off of this edge down here. Just because, like I said, this has got a rounded kind of fillet in here. And we want this to sit just perfectly flat. And I want to make sure you can feel when it starts touching the fillet. And I want to make sure that it goes a little past the screw hole before it touches, so I know that we've got it nice and flat. And so the next thing we do is we get a little bit of thermal grease. And it doesn't take a lot. This is some leftover from when I was working on a computer. This is like the CPU grease. And you just wipe a thin layer across like that. I'm going to go ahead and have this screw sitting in here just in case it has a little issue getting through that hole. And then we have our screws that are going to hold this down. And they fit through like that. And then we go to the other side and we put a little lock washer and a nut. And tighten them down. So I'm going to go ahead and get the other one drilled, get everything mounted, and then show you how we're going to hook the wires up when we get this all done. And here we go. We have the 2 resistors mounted over here on these heat sinks. We did the chassis ground to the power connector on this bolt here. Here's our other power resistor over here with the ground wire coming over. There's the hot wire coming over to, that would be the cathode of the 300B. Same thing over here. And then we have, I put a little piece of the old wire that was holding the resistor up into the ground here so that we have a nice spot here to hook our ground lead up for checking voltages when we have to do any future testing. So that gives a convenient ground spot there. So I think that's it for this amp. I think we're done. I'm really happy with the way these aluminum heat sinks turned out. And I'm going to do one last pull on the audio analyzer suite to see what this coupling capacitor reduction did, and I think this is ready to deliver to the customer. I did do some tube rolling, and the Russian 6H8C, which is about a $10 clone of a 6SN7 that's made in Russia, actually sounds really good in this amp. So let's get a pull on the audio analyzer and wrap up this series. Okay, this is the final build of this amp. Got the bottom screwed on it, finished up. You saw the resistors and everything put in it. You know, it's all done with the good capacitors. We did lower the coupling capacitor to a 0.22 UF, and we've got a tube amp Doctor 5AR4. We've got a couple of Soviet 6H8C driver tubes, and then we've got a couple of the Shuguang, probably pronounced that wrong, but 300B-Z output tubes. And none of these are like hand-picked ringer tubes. They're just stuff that I had around that I rolled in, and I feel like this is probably the best combo. The PS vanes had a little more distortion, and to me they just don't sound quite as rich as these Treasure black-coated tubes do, but they're another $225. And so that's something we'll go over in the final video, is this worth doing? But anyway, the frequency response, I did realize that over here, the default is set to 0.2 volts RMS, or 2 volts MS, and I feel like that for a tube amp, it needs to be probably more around 1. Seems to get more predictable results. So anyway, let's look at what the frequency response turned out to be with the adjustment to the coupling cap. And here's the final frequency response. Here we are down at from 20 hertz all the way up to 10K. There's absolutely no roll off at all. And then there's a couple of dBs on the top end between 10 and 20K. I'm not concerned about that. I think this looks really great. And so let's do a final pull on the THD versus power and see what this thing does on that. And this is just so night and day different from what we started with. The distortion is way down here. Follows the input signal all the way up to 2 watts. We got a 0.6, 2.5 watts. We got 0.6 harmonic distortion, which is just almost nothing. At 1%, we're making almost 5 watts. And then where I would really, I'm saying that where I'd start, getting concerned about the distortion is when you get up around 3 to 4% distortion, and we're making, at 3, we're making 7 watts, and at 4% distortion, we're making 4.6 watts. Where before, that advertised output of this amp, it was off the chart. I mean, the program shut down because it was over 10%. So we've now got this amplifier delivering the as advertised wattage at a reasonable distortion level. And if you've got some efficient speakers where you're only needing 3 to 4 watts, it's going to be down at 1% distortion. And if you've got, like me, and you're running something like these Clips speakers that only need a watt and a half, you're going to be at a 0.5% distortion. This thing's going to sound fantastic. So I'm going to go hook this up to my system with all these final changes, listen to it for a day or so, and then do a wrap-up video on, is this worth doing? How good does this amp really sound? And just wrap up this whole series. So hope you're enjoying this. If you are, please sub to my channel. Please like the video. And I'll see you soon for more tube amplifier fun. Have a great day.